I'm always down to focus on like concept, theory, personally, because I feel like in the past, those are ones that, at least in the beginning of the semester, would sort of like throw me for a loop during exam. And then maybe some like important concepts from the beginning of the chapter, like stuff that's maybe a little less fresh, or just sort of my thoughts.
Okay. Let's see. Let's start with something that, like, it's not that usually students don't find it that it's complicated to kind of understand and grasp, but it's easy to forget. Um, just because there's like this one extra little piece that people go, oh yeah, that's right. And that's that second fundamental theorem of calculus. Um, so like if f of x is equal to the integral from, let's just do 1 to x of sine, we'll just make it simple for this one, sine of t dt, then see part A, what is the derivative of f? And we'll use the second fundamental theorem of calculus, even though you could go through the integral with this one, plug in the bounds, and then take the derivative. Like you can totally do that when it's possible, but that theorem shortcuts it, so you don't have to. Because if you integrate and then take the derivative, you're going to end up right back where you started anyway. You're just going to have a different variable, and that's it. Like the original function is, you're just going to get right back to it. So what would your answer be for this?
Would be
Would it be the original function?
Yeah, but what would be in it? It'd be sine of
x.
Sine of x. Okay, and then for B, because sometimes it might ask you to take it a little bit further. Like, what is the derivative of f at x equals pi over 2?
It's just sine of pi over 2.
Yeah. And for whatever reason, that tends to throw people a little bit because they're just like, oh my gosh, what do I do now? It's like, well, just keep going. Just plug in whatever x value is into your derivative. And then and then evaluate it if you can. In this case, it'd just be a 1. Okay, so let's make it a little bit more complicated. So if f of x is equal to the integral from 1 to, let's make it x squared of root 1 plus cosine of t dt. And then we'll do the same sort of deal. We'll take the derivative, and then we'll have a second part. So this one, you would not be able to integrate it. Like, you don't know a formula or a technique that deals with this. Like a U substitution would not work, nor anything else that we have. So this one, you're kind of forced to use the theorem.
I think it's been a little while since I've worked with this, but isn't it square root of 1 plus cosine x times 2x, or 2x square root 1 plus cosine x?
1 plus cosine, and then what did you say the angle was?
Oh,
say-
x squared, excuse me.
There you go.
I had said x, what's x squared?
Yeah, so where is this this 2x coming from?
The derivative of b.
Yeah, the derivative of your upper bound. And that's the part that is easily forgotten. So like if this was a multiple choice question, you can be guaranteed that one of the solution or one of the choices would just be this. It would just have the radical, and so and then just replace the t with the upper bound, but you still need to put the derivative of the upper bound in there. So why do you have to put it there? Like just because?
I actually don't know. I just know to do it.
Which is good enough most of the time, but does anybody know why?
Isn't it like the chain rule?
It's the chain rule. Because essentially, you know, if you were going to go through it step by step by step by step, you would integrate it, plug in the bound, and then you would find the derivative. So your bound has been already plugged in. So you've got this x squared that's running around now inside of your function. So you have to, when you take its derivative, you're going to eventually take the derivative of that x squared because of the chain rule. So you're using that second fundamental theorem of calculus combined with the chain rule, just kind of all at once and all at the same time. All right, and then so if it said, okay, what's the derivative at the square root of pi? Just the same thing as before. Just take the root pi, plug it in for your x's, and then evaluate it as much as you can. So the square and the square root cancel out. And then what is cosine of pi?
-1.
-1.
-1. So 1 minus 1 is just 0. So that whole thing just cancels out. And it just goes to 0. Okay, so something that's just easy to forget, and that's that chain rule. There you go. All right.
I had
So-
a question about this one. The concept of having the derivative be in the variable t equal to a function in the variable x, that really threw me for a loop when you wrote it that way. Can you explain what that means conceptually when someone writes that mathematically?
Can you say that again?
So in the, well, I don't know if you're allowed to talk about the quiz, but you were talking about a velocity function with a horizontal axis of t, but the variable was an x. It was,
Well, in
it
that
was
case,
b of
it's not
t
the
equals
second
ln
fundamental
x
theorem of
squared over
calculus.
x.
That it's not the fundamental theorem of calculus.
Oh, okay. What does that mean? Okay, maybe we can address it later then, because I'm
Well,
trying to wrap my head around that one.
Well, if you're going from, if you're, so say you have a velocity function,
Yeah.
v of whatever, v of t, v of x, that part doesn't matter. And you want position, then you need to integrate the velocity.
Yes. Absolutely.
So
Yeah.
there's no derivative in there. So there's no second
Yeah.
fundamental theorem of calculus.
Imagine it was v of t going to v of t said it was equal to ln of x squared over x. I didn't know how to translate that.
Oh, via t.
Yeah, imagine it said v of t. I feel like I'm missing something.
So like this.
Yeah, something
Wait.
like that. Yeah.
It was probably just a typo.
Oh, well, I've spent like a very long time trying to figure out how you have a different, the only thing I could think
So-
of that I had mathematically seen that switched variables was the second fundamental theorem of calculus. That's why I went to it.
Mhm.
But
So let's just say that wasn't a typo, like it was on purpose.
yeah,
Because in calculus 2, they might actually do that to you to see if you're paying attention. So if you did have to integrate something, so let's say you had to integrate, I don't know, let's just do x dt. What's the variable?
well, it looks like it might involve something to do with implicit differentiation.
Nope, what's the variable?
Oh, x,
No,
t,
t, because it's d what?
it's the derivative.
It's d.
Oh, it's the horizontal. When you say
T.
variable, do you mean the horizontal axis?
Nope. And what letter comes after the letter D?
T.
That's the variable. So
Okay.
any other letter would be considered a what?
I don't know.
Constant.
Oh, okay.
So then it would be xt plus c. Because whatever.
Oh, I see. Oh, I see.
That's
Okay,
the
so
variable.
imagine the x is a 1 or a 2 or a
Yeah.
3.
Because this is saying you have to integrate with respect to t, right?
Mhm.
So every other letter is now just a constant.
But so in other words, that one on the quiz that said vt equals ln of x squared over x, that was a typo.
Yeah.
Oh. Okay. Spent a lot of time. I spent a lot of time trying to figure that out.
The fun things of, yeah, type stuff out. Okay. So anyway, so you guys think you're okay with this?
Yeah.
Okay. All right.
Yeah, I am. I mean,
Okay.
for the let's say it was multiple choice, would you say, hey, use the second fundamental theorem, or just based on that form, we would just recognize it?
Yeah, it might say to use it, but it might not. It just
Mhm.
depends on what you're doing. But if you're given a function like this and then it wants the derivative, I would just automatically use a second fundamental theorem.
Mhm. Okay.
Especially if you don't know how to integrate whatever's in there, then you're going to have to use it. The first example, you can get away with not using it, but
Mhm.
you're just eating up time that you don't need to use or to spend. So yeah, if it was just stated just like this or this, I would just automatically default to the second fundamental theorem, even though it didn't tell me to use it.
Okay.
All right, let's kind of play with this integral right here just a little bit. Let's make it 1 minus cosine, root 1 minus cosine of t times sine of t dt. So what would you do, or what would you try to integrate that? Like, does it fit an ln? Does it fit in an inverse trig function? Can you just integrate it directly? Is it a u sub? Is it impossible?
I mean, just right, it just sort of seems like you can do it directly.
Okay. So what would it integrate into? Because if you can do it directly, that means you can just look at it and just spit out an answer.
I would set 1 minus cosine to a half.
As the answer.
Add 1 to 3 halves. So that would be would it be -2/3, -2/3 sine to the 3 halves times cosine times negative cosine?
Let's see, -2/3 times, what was the thing you said?
-2/3 sine to 3 halves times negative cosine.
Like that?
Yeah. Yeah.
It's close, but not quite, because are you trying to integrate like each piece?
Yeah, I did it separately, but I guess I would need like, it would need to be separated by a plus or a minus to do that.
Yeah. So
Okay.
yeah, if there's like two things being multiplied
Multiply.
together, you can't integrate each
One-
factor.
So I see that the one is closely related to the derivative of the other, but I can't quite put my head around it.
Okay.
I think we do a u substitution on 1 minus cosine of t.
Yeah,
Yeah.
I agree.
And usually, like if you got a radical and then other stuff like on the outside, your u sub is most of the time is going to be whatever's inside that radical. So then your du would just equal
It's just a sine of t, right?
yeah.
Sine t dt.
Uh-huh. Yeah. So now if you switch everything into terms of u, what's really inside that interval?
Just be square root of u du.
Yeah. So you can either think it or change it out on paper. So it's just, the 1/2. So that first answer we had, there were elements of it that were correct. So like the 2/3 and the exponent of the 3 halves. Those were great. We just had some extra pieces in there. Threw it off a little bit. Okay, and then just switch it back in the terms of t. All right, nice job. All right, let's try this one. 1 minus cosine squared inside that root, dt. Shut off. There we go.
Is would you use the the Pythagorean theorem?
Yes. Yeah, because 1 minus cosine squared, what does that equal?
Sine
Sine
squared.
squared.
Yeah. And then you can root the square. So you're just integrating sine of t, which is
Cosine of
cosine.
negative cosine.
yeah, negative cosine of t plus c. All right, nicely done. Yeah, that's how those, like all those trig identities that you went over in pre-calculus or your trig class, this is why you went over them, because they come back in calculus. Not that you have to prove them, but you got to know like what identity is what, so you can actually integrate something like this, because that was really the only thing that would work. A U substitution would not do this. It's not an inverse trig function. It's not an ln. It doesn't fit any other format other than using a trig identity. Okay. Yeah. I have a question right before I said that, and now I can't remember what that was. Oh. What is in every answer when you are asked to evaluate an indefinite integral?
Plus C.
Yes. So every time you have an integral like this one or this one, that plus C is going to show up in your answer. So if it's not in there, don't select it as an answer, because it's not right. You're missing the plus C. So if your choices are like between like sine of x and then sine of x plus c, because you got to integrate something, you're going with that one, not with this one. Okay. Let's see, how are you guys on like Riemann sums with a table?
I haven't done one of those in a while.
Okay. All right, let's. Okay, now I gotta make one up. Okay, let's just go 0, 5, 10, 15. Five. Okay, then R of X. Keep on small, so like 1, 3, 2, 4, 0, and 1. Okay, so water is leaking from an aquarium at a rate R of X where R is in gallons per hour. So use a Riemann sum. To find the amounts of water that has come out using the table. All right, so which one do you want to do? Do you want to do a left or a right? And it will tell you in the problem like which one to do. I'm just giving you the choice and then we'll just do it.
I'll just do a left side one.
The left one. Okay, so if it's a left Riemann sum, and we're gonna let's use four intervals from 0 to 20. So your intervals are going to be suggested or determined by your table because you're using the specific values that they gave you. So you can't like use any other numbers than the ones that are up here. Like, so don't start making things up. Okay, so if we're going to use the left Riemann sum, you're going to go up to your table, and then your first interval, you're going to start with your first value, the 0, and you're going to go from 0 to where? Like your first interval will go from 0 to which of these numbers? 5, 10, 50, or 20?
To 5.
5. So you're getting the width of that x interval. So from 0 to 5, what's the distance in there?
5.
5. And since it's a left interval, that means you're going to choose one of these two values. So since it's a left one, you're going to choose either the 1 or the 3.
Be the 1.
You're going to do the 1. Why the 1?
Because that's on the left side of the graph.
Yeah. Like if you're physically pointing at the two values, if it's a left interval, you want to choose the one where your left hand is pointing. So that would be the 1. And then you move on to your next interval. So that would just be from 5 to 10. So the distance from 5 to 10 is
Still 5.
still 5. And then what value between these two guys are you going to choose?
The 3.
3, because that's still on the left. Okay, then you move to your next one. So from 10 to 15, it's the distance of 5 again. And the value on the R's that you're going to select is the 2. And then finally move over to 15 to 20, so that's 5. And then the value to select would be 4. And then you just got to multiply them and then add them together. So 5 plus 15 plus 10 plus 20. And that is going to give you a total of
50.
50. And then what are the units?
Gallons.
Gallons. Or is it gallons per hour?
It's just gallons because it's sum of everything over the time.
Yeah. Also, too, the problem can sometimes tell you what the units are supposed to be. Like you're supposed to find the amount of water that's come out. Well, if someone asks you like how much water is like in a tank or how much water is in that bucket, you don't tell them 50 gallons per hour. It's like, what? You just give them an amount. So there's no timing. All right, so let's switch it from a left to a right. And then same thing, 4 intervals. 0 to 20. So you're still going to go from 0 to 5 as your first interval. So it's still working with just 5, but out of these two values, you're going to go with
We're going to go with a 3.
3. Okay, and then from 5 to 10, it's 5 again, and then your value to choose,
2.
2. 10 to 15, that's 5. The value,
4.
yep. And then 15 to 20 is 5 again.
That's 0.
0. So if you look at your calculations between a left and a right Riemann sum, like your values are almost the same. Like most of the ones that you're going to multiply together, they're going to be similar. There's just going to usually just be one that's different. Okay, and then just again multiply them out. Add them up, and then you should get
45 gallons.
Mm-hmm. All right, nice job.
Would you ever ask us to deduce whether the water rate is increasing or decreasing based on knowing which is greater, the left or the right? Or would you, I guess, are you gonna, is there any sort, I'm kind of going back to what she was saying earlier. There's a lot of like questions you have that ask us insights into how the math works. So I was just wondering if like you might ask us to deduce something about the original function based on the left being greater than the right.
This, like for this problem, I don't think I can do that because it's not all that realistic. There are times where it could. So if the left Riemann sum or your yeah, the left one was the larger of the two, sometimes it might ask you like what can it say? It could say is the function increasing or decreasing. It wouldn't ask you about the rate because you got the values in there.
Yes, it's the original function. I'm sorry, I
Yeah.
asked it wrong.
So it would have to define a function as the integral. So if f of x is equal to the integral from 0 to x of r of t dt is f, let's see, what can they do? Like increase, like an increasing or decreasing function. Is this kind of like what you meant?
Yeah, basically.
Okay, so with this one, because no, I can't ask that question either. I'm trying to think of what would be a good one. I think it would have to, and if f is increasing, is f concave up or concave down? Trying to think if that's right. I might be missing something in here. That's basically what she's asking about. And so what you can do is, since you know the left one is the bigger one, that's automatically your upper sum. So since you're increasing, let's just draw an increasing curve like this. That's the overestimate. Oops.
Actually, it's a downward curve on an
Yeah,
upper us. If the
It's like
left
this.
is the upper sum, it should be going down, shouldn't it?
Yeah, I was like, there's some, it's not matching up with this scenario.
Yeah, and Matt, it's
Um,
basically on your notes, and that's why I was asking about it, because
Oh, okay.
the downward one, I noticed that in the book, correlating back to the book, there was a discussion in the book in your notes that kind of implied this whole thing of if the left is the upper sum, then you can do something about the original function. That's what I wanted to make sure. If I get asked about that, I don't have my head wrapped around it.
Do you remember where it was in the notes?
Yeah, it was on 5.1 through 5.3 when you were doing doing the rectangles over the curves before you introduced. It was 5.2. Yeah, it's like if the upper sum is the max and it's on the left, then the function is decreasing. And I just want to make sure if you're not going to ask about it, great. If you are, then I just want to make sure I have it right.
It's like, yeah, that would be true. Trying to find where that was stated.
Well, I deduced it from the book and your notes.
Oh, I see.
And so I was concerned because the book started talking about how the upper sum,
Mhm.
you were using left and the book was using upper sum. And then the book was talking about a correlation between upper sum and being on the left, and what you could deduce from the nature of the original function. And I know that sometimes you like to ask questions that ask us to deduce the math or show our understanding of it. So I was
Yeah.
asking about, would you be seeking us to understand about left being higher than right, upper and lower, that type of stuff?
Like it's possible. So yeah, if the function is decreasing, then the upper sum would always be a left Riemann sum,
Yeah,
because that would be the only way that your rectangles could be drawn outside the curve to where it would get on the left, that would make it an upper.
right. Okay. So get my head around that, in other words.
Get your head around that?
Yeah, in other words, I should really understand that concept and make sure I digest it.
I thought you were telling me to get your head around that. I was like,
No,
oh.
no, me, I'm talking to myself, sorry. Sorry, I'm talking to myself, I'm sorry.
That's okay. All right. Let's see, what other kinds of concept questions can I really ask? Like, there's not a whole lot that I could do in this chapter, because there really isn't a whole, like, it's still just like the basic type stuff. Not to trivialize it, but it's like you don't really get into a whole lot of, like, I mean, there really isn't much to integration that we've looked at. And so a lot of that stuff is going to come calculus 2, because the majority of calculus 2 is integration. Because you'll do chapters 6, 7, 8, and 9, and maybe 10. And most of that is just on integration techniques and a lot of the stuff that you can do with it. Okay, let's talk about this one though. This one's kind of in there. Let's say you were going to integrate from 0 to 5 of the absolute value of x. And it wants you to give a value for that. So how would you do it?
Would it be the absolute value of x squared over 2 from 0 to 5?
Well, one way to find out is just to do
Would
it.
you do it?
So change it to this. Or wait, are you saying that was the answer?
Well, I've never done the integral of an absolute value before, so I'm thinking it's just the answer would be x, the absolute value of x squared over 2.
Oh, okay, I see what you mean. That would be a good guess, but not exactly. And you're right, we've never really, like, we haven't done like you've done at least one of these, but we haven't talked about a formula for it. So
Would we do it graphically?
yep. So if you come across an integral and it's not fitting a formula or a technique that we've gone over, that means there isn't one to use as opposed to using the graph. So the graph of absolute value, what does that look like?
It's like the it's like a
V.
big V.
Yeah, V. So we're going just from 0 to 5. So all you have to do now is just get the area of that triangle, and that would be your answer. So as long as you know the area formula for it, you're good to go. So just 1/2 times the base times the height. What's the base?
5.
Okay. And what about the height?
Also 5.
Yeah, how do you know that? Because some people are just going to assume that it's the same number. And it's the same number all the time, but that's not the case. So how do you figure out the height? Just in general.
Well, isn't with the graph, it's I mean, just the slope, just where the line is, it's like 1, the y would be 1, and 2, the
Yeah, because the height would go with this x value, right? So if you know the
Mhm.
x, how do you always get the y?
You plug it into the
yeah,
function.
just
You just plug it straight into your function. So whether it's a
Okay.
rectangle, triangle, circle, whatever, if you know the x value, you want to know the height that goes with it, just plug it into your function. And that'll give you the y value or your height. So that would just equal 25 all over 2. So there was, let's just take one. It was on the study guide, but I'll change it a little bit. Let's go from -2 to 1 of x over the absolute value of x dx. So this one, there's no formula for it either, but you can still use the graph as long as you know what the graph looks like. But every once in a while you come across one where it's like, oh, I don't know what that is. So if you don't know what this looks like, how would you graph it?
Or plugging values in?
Yeah, just go back to your algebra 1 pre-algebra and just start plugging in values and see what comes out. So if x is 1, the y value would be
1,
if x is 2,
1,
if x is 3,
1,
if x is 50.
1.
Yeah. So as long as it's higher than 0, it's the curve is just going to be right at 1. It's going off that way. All right, so now let's try the negative values. So when x is -1,
-1.
When x is -2,
-1.
-38,
-1.
-1. So if it's less than 0, it's going to be a -1. Going off that way. So we want the integral from -2 to 1. So the area of this rectangle here and the area of that rectangle there. So a rectangle is just base times height. So for this first rectangle down here, the base is what?
-2.
And the height?
-1.
Okay. So you got to be careful with that because your lengths are always positives.
Gotcha.
But since the area is underneath the x-axis, what does that make the value?
It would make it negative.
Make it negative. Okay, and then add it to the one that's above the x-axis, so base and height are both 1. So your total would just be -1. So if it's a definite integral and you're going, how do I integrate that? It might not be something that you're gonna really integrate. It will probably be something that you have to graph and then use just your geometry to get the area and get the area that's under that curve. So it could come out to a triangle, it can come out to rectangles. It could be part of a circle. I'm trying to think of what other, those are pretty much like I think the only shapes. It's not going to be like an octagon or something. Okay. All right. Any questions on these two? Okay. All right, I'm going to give you a couple of integrals and don't say anything about them just yet. Let me write them down. So just kind of think about how you would integrate each one. So don't say it out loud just yet. Just to give everybody a little time to kind of look at them and process them. Okay, there's your first one. So don't say anything just yet. There's your second. Third. Fourth. And fifth. Okay, so give them a little bit of thought. Because one of the challenges for this chapter is being able to look at an integral and know what technique to use. Okay, so when you're going through the integrals, because it's not going to tell you like which technique to use, like you have to decide. So when you're trying to decide, you've got a list of things that you can kind of run through and go, okay, does it fit this? Does it fit this? So the first one is just direct. Like when you look at that integral, like, can you just get a solution, like just integrate it and get an answer and be done with it? And if the answer is yes, then great, just integrate it and then you're done. If the answer is no, then you're going to have to run through some more options. So the next thing you could look at is a U sub. Does it fit an LN? Especially if you've got a fraction. The fourth one is an inverse trig. And that's pretty much it. When you get into calculus 2, they'll add to that list. But for now, it's really just these as your choices. So if it's direct, that would be something like if you were just going to integrate like something like, x dx. Like there's no technique to really use. You just kind of integrate it. So just 1/2 x squared. Let's see. So that's what I mean by direct. So for all of these here, it's not necessarily a direct. They're not necessarily direct intervals. You're going to be using one of these 3 techniques to get an answer. And for some of them, you might end up using 2. Just depends on what's in there and what you like to use and what you see. Because some people like to use a U sub with an LN, some don't. Just depends on the individual student. All right, so for part A, which one of these do you think it really fits? Or which one do you think would be like the best choice?
For A is ln.
So when it's going to fit an ln, what's the key? Like, what are you looking for? What do you want to have happen?
That the derivative of the bottom is on top.
Yeah. So especially when you've got a fraction, that's like the first thing I check. Like I look at this denominator and go, all right, is this the derivative of this up top? And in this case, it is. Derivative of x squared is 2x. The 3x goes to 3, and the -4 just goes away. So then it's just ln of the absolute value. And then what thing goes in there? Is it the top or the bottom?
Bottom.
Yeah. And don't forget your plus C. All right, nice one. All right, part B.
Another ln.
Yep, another ln. Because the derivative of that denominator is just 2x. All right, now in part B, I left something, or I changed what I did just a little bit as far as the answer goes. Like what's different about the answer for part A as opposed to part B?
You have the parentheses instead of the absolute value because it has to be positive because of the square. So if this was multiple choice and you had the parentheses and then you had the absolute value,
I wouldn't give you both choices like that.
Okay, just wondering.
Okay to have the
Because, like-
absolute value.
Yeah, that would be a little mean. And if it was a free response, if you had this, if you actually put the bars in there, I wouldn't take points off for that. I would accept it. Just be aware, and I'm doing that because it's calculus 1. When you get to calc 2, your professor might get a little picky on that. So just be aware that just because you're not getting marked wrong for it now, doesn't mean you won't in the next class.
Okay, thank you.
Yeah. All right, what about part C?
That one will do an inverse trig.
That's an inverse trig. Because the derivative of your denominator is not on top. You need it to be a 2x like it is in part B. And it's not a u sub either, because you would need a 2x for that as well. So your only other option is your inverse trig. So which of the three functions doesn't have a radical in the denominator? Is it inverse sine, inverse tangent, or inverse secant?
Inverse tangent.
Inverse tangent. All right, so, and if you want, you can pull this, this 2, we can pull it out to the front. You don't have to, but sometimes it helps just to kind of see it. So with inverse tangent, it's 1 over a. So in our case, it's going to be 1 over
2.
2
2.
times inverse tangent or arctangent. And then the argument that's in there is going to be the u over the a. So we know a is 2. What about the top?
That's just x.
Just x. Let's see. So the u and the a, you're getting them from that denominator. You just got to square root the two terms. So square root of 4 is your 2. Square root of x squared is your x. And then just simplify it so the 2.5 cancel out. And there you go. All right, what about part D?
More inverse trig.
Looks like arc sine.
Yeah, that one's going to be an arc sine. So the 2 in the numerator, that's still there. And then is there anything out in front of the arc sine? Because there was
2.
for inverse tangent. What about arc sine?
No.
Mm-mm. So that 1 over a stuff isn't in the inverse sine or arc sine. And then what's in here?
X over 2.
X over 2. All right. And then this last one, what do you want to do with that?
U sub.
U sub. Okay, so give me something for the U.
4 minus x squared.
Nice. Could you choose just the either negative x squared or x squared?
Yeah.
Like, would that work? Or do you have to go with 4 minus x squared?
4 minus x squared.
Yeah, you really want to go with 4 minus x squared. If you're choosing something inside of a radical, you typically want to choose the entire inside, not just little pieces of it. Okay, so your du is going to be negative 2x dx. So you've got everything accounted for except what?
You add the negative.
Yeah. All right, so you can think it in your head or write it out, but that 1 over root u is really just u to the negative half. Which is going to become,
Negative 2 square root of 4 minus x squared.
yeah. All right, nice job. Okay, any questions about these? So they look similar, but you can get completely different answers for them just by changing one little thing. Okay. All right. What are you just dying to ask about?
On the study guide, I was having a hard time with part F and part G.
Let me pull that up.
Which number?
Yeah, I was like,
So like F was like the integral from of 2x squared minus 2 all over x cubed minus 3x plus 4.
oh, okay. So on number 1.
Yeah.
So with that one, excuse me, I would pull the 2 out. So it'd be x squared minus 1 on top. And then the denominator is still the same. That's the x plus 4. There we go. So if you look at your denominator, what's the derivative of it?
3x squared minus 3.
Yeah, which is really close to the top. So if you multiply the top by 3, then you would have it. Well, you can totally do that as long as you do what?
You do the same to the outside.
Not the exact same thing.
Well, the inverse of it.
Yeah. So 3 underneath or a 1/3. So now it fits exactly what you want. So that'd be 3x squared minus 3 on top. So 2/3 times ln of the absolute value of just that denominator. And you can leave it like that.
Okay.
Oh, that was F. And then what was the other one? G?
Yeah.
Okay, so G is similar to it. So if you look at G, we've got that 2x minus 5 on top. And then the x squared minus 8x plus 20 underneath. So the derivative of that denominator is 2x, but instead of a minus 5, you really want a what?
Minus 8.
You need a minus 8. So we're going to force it to be a minus 8. So what would you have to add or subtract to a negative 5 to make it a negative 8?
I have to subtract a 3.
Yeah. So you can do that as long as you do what?
Add 3.
Add 3. So this is that adding by 0 technique. So if you need to increase or decrease a constant, this is one way to do it. And so if you combine the negative 5 and just the negative 3, that gives you the 2x minus 8 that you're looking for. And then you still have to deal with this extra plus 3. So how did we deal with that?
Do you
Okay.
just make it like another
Break the
term?
fractions.
Yeah. So you just split it. Off into its own fraction. So your first integral, because we forced it to fit what we were looking for, we know what that one's going to be. That one's just going to be the ln absolute value x squared minus 8x plus 20. But this one over here, it's going to require a little bit of work. So it's not going to be an ln. It's not a u sub. We can't integrate it directly. So if we look back at our little list of options, it wasn't this, it wasn't this, it wasn't this. So it has to be
Inverse trig.
inverse trig. So which inverse trig function do you think it's most likely going to go into? Inverse tangent, sine, or secant?
Tangent, maybe?
Yeah. And what kind of leads you to that?
If we complete the square, it'll be plus 20 at the end, right?
Yeah, but you can complete the square and other problems where it would lead you to inverse sine. So what about this one makes it inverse tangent? If it's the difference between inverse getting to an inverse tangent and getting it to an inverse sine is inverse tangent does not have a square root in the denominator. So if this was underneath a radical, then you'd be going towards an inverse sine.
Okay. I see.
Okay, so let's pull that 3 out. Okay, and then for the denominator, he was totally right. We are going to complete the square. So with x squared minus 8x, what number completes the square?
16.
Okay. So if we pulled off 16 from 20, how much is left over?
4.
Yeah. All right, so let's complete that square. Let's factor it. So x minus 4 squared plus 4. Okay, so it's going to be 3 over the a, which is 2 times inverse tangent or arctangent, either one, of what?
X minus 4 over 2.
Yeah. And then there's something else.
Plus c.
Yeah. And I'll put the ln back in there too. All right, and there you go. All right, any questions on either of those? Okay. All right, I actually have a question for you guys that I just thought about. This was from, I think it was quiz 11, Might have been quiz 10, but I think it was 11. Where it was really similar to it. So find the average value of f of x from x equals, I don't know, 4 to x equals 9. And the area between f, x equals 4, x equals 9, and y equals 0 is 55. So the question on the quiz is pretty similar to this. The numbers were just different. So first of all, what is the formula for the average value?
1 over b minus a times the integration of f of x equals f of c.
That's close. Like there's no f of c in there, but there is something that was left out.
A and
A
B.
to B.
Oh,
B.
Yeah, a to b. So it's always going to be a definite interval in there. Okay, so we're looking for the average value. So we don't know what this is. So we have to just start plugging in numbers and see what happens. So in our case, what's the b?
9.
And the a?
That would be 4.
Okay, and this is where a lot of people kind of panicked and they're just like, oh my gosh, how do I do that? Because you don't know what f of x is. And so they were stuck because they couldn't integrate anything. But there was a piece of information that they just didn't see or didn't read or something. But what does a definite integral represent?
area
The area. Do you know what the area is?
That's
55.
given.
Yeah, it's 55. So you didn't have to worry about integrating it because you knew the area. So just stick it in, multiply it out, simplify. So your average value is 11.
So the average value, is that just like on the graph, that's just the average area across between
It's
those 2 points?
It's the average y value between all your points. So if you looked at like if you stacked all your y's together in a list, this would be the average of all those y values.
Gotcha.
Because it's the average value of the function. And anytime they're talking about the function, that's always just a y.
Can we talk about number 7 on the study guide?
Sure. Find it. Let g be a twice differentiable function.
Yeah.
Okay. All right, so if we know that g of x equals the integral from a to x of f of t dt. So the first one was, what is g prime of x? So what is the derivative of g. So in order to figure that out, what theorem are we using?
That's the second
Fundamental, the first
theorem.
one?
Yeah, that second fundamental theorem of calculus.
Mm.
You're taking the derivative of a definite integral. So according to the theorem, it's just your function that was in there, but now the variable switches to what?
X.
X. Okay, then B, what is the second derivative? So if you're taking the derivative of this stuff, so we want the derivative of f, which is just f prime. Okay, so g of x, so this function is going to be increasing when f of x is what?
So if it's greater than 0,
Yeah, or if it's another way to say greater than 0 is just
positive.
positive. Because a function is increasing when its derivative is greater than 0 or it's positive. So the derivative of g is f. So if that's positive, that means that g is going to be increasing. So then the flip of that would also be true. So g of x is decreasing when its derivative, or f, is negative. Or less than 0. Okay, now for E and F, it's talking about the concavity. So that's referring to your second derivative, which we know is the first derivative of F. So if it's concave up, that means your second derivative, or F prime, has to be positive or greater than 0. And if it's concave down, then that second derivative, or F prime, has to be negative.
Can you quickly draw a vertical and horizontal axis, like kind of what I sent you an email? I want to make sure I got this one right. The X's and the T's and everything. You know, like draw the f of x, where f of x is, g of x, and f of t.
So this would just be F,
Mm-hmm.
right? Doesn't matter if it's F of X or F of T.
Okay.
And then G, that's going to be a little harder to do without.
Oh, but it's g is the original. Oh, think of it as the original. It's the integral of f, so it's the original function.
Yeah, so if
Kind of does that S curve thing starting at 0.
this is F, that's a third degree. G is going to be a fourth degree, so it's going to be like a W.
Uh-huh.
So that's going to be something like this, but again, we're not really going to know a whole lot about G.
Mm-hmm.
Because I don't know exactly how far up or down it's going. So it could be slid up, it could be slid down, because I don't know any points. So I'm not sure where we're going with this.
Well, I'm still, you know, like I sent you my interpretation, and you know, of the concept of f of x, and in this question number 7, it confused me even further, because I was thinking of f of x as a, like the horizontal axis was t. I don't want to confuse everybody with my confusion, by the way.
Okay, then I think we need to stop.
Yeah,
There, it doesn't, like t and x, that's not gonna, that doesn't change the function. Like f of t and f of x, that's the same function. Right, because it's just different things being plugged into the same function. It's not like we're changing. It's like, I think you're looking way too deep into this. And I think that's part of your confusion because you're wanting it to be something more complicated than it is.
mhm.
Um,
So maybe it's easier if I take the x and the t out of my head.
maybe. I don't know. I mean, the only reason why, because if you're struggling, like, oh my gosh, this is like these are different variables, like that's just because it would be weird to integrate f of x with the and then plug in x as a bound. Like, you see what I'm saying?
Mhm.
Like, it would be weird to have f of x going from like 0 to x. So to avoid having these things be like the same exact variable, they made one x and then made the other one t.
Okay.
That's pretty much it. So it's not like we're having two different variables in here. It's like they're both essentially being treated as like a horizontal axis here. But they didn't want to use the same letter because that would just have, that leads to just other questions and issues. All right. All right. Anything, any burning question that's kind of quick? Then there was silence. Okay, well, that's going to be all the time we have for today.
The exam, that's all just basically all in chapter 5, right?
Yeah. I mean, you still have to know derivatives because like when you do a U sub, you got to know how to do the derivative of that U.
Right.
So I mean, that still comes into play. But yeah, I mean, the goal is, or the point of the exam is chapter 5.
Cool.
And it'll be around like 30, 25, 30 questions, kind of like usual.
Mm-hmm.
But, okay.
Yeah. Is
the final a similar length?
Yes. So exam
Great.
4 is 25 questions and the final is 30.
Okay. And do you have a time set for the final review yet?
Yeah, it's the same time next week.
Okay, great. Thank you.
That should have been, I think it was.
Maybe it was. I just couldn't remember offhand.
Okay. Yeah, it's same time and place next week.
Yeah, Wednesday, May 12th.
Yeah.
What our final is May 12th?
No,
the
the next
review.
review.
Oh, the
Next
next review. Oh, thanks.
The
Sorry.
final is next Friday.
Yeah, okay, thank
Yeah.
you.
Someone's eye just got real big.
Yeah, mine.
What?
Well,
Yeah, the
thank you
reviews.
so much for taking the time.
Oh, you're welcome. Email me if you have any other questions. Try to take the quiz before the exam, because you can use it as a study tool to kind of help highlight and go, oh, wait, I don't know exactly what that is.
Did you extend the quiz deadline?
Oh, wait, yeah, I'm sorry. I forgot it was, I did not. I was thinking
Oh,
of
okay.
and pre-calculus has their last quiz on this Friday. So I just forgot.
You had mentioned in one of your announcements, though, that you might try and grade exam 4, so we could use that as a study guide for the final.
Yes. Mm-hmm.
Okay.
Yeah. So yeah, my goal is to get that exam or this coming exam graded so you can use it to help you study for the final. So hopefully it's not a lofty goal. All right. Well, thanks for coming.
Bye.
All right.
Thank you.
See you later.
I'm